All right, let's take a look at number 11, please. So we're given this function. First part asks us to find the local extrema. So to find the local mins, local maxes, we need to figure out when the derivative is 0 first, and then we can use a number line to determine that. So let's find dy dx. We're going to need product rule here. Derivative of x is just 1 times e to the negative x, plus x times derivative e to the negative x is e to the negative x times derivative of negative x is negative 1. We want to figure out when this is equal to 0. So we have e to the negative x minus x times e to the negative x. So we can factor in e to the negative x out, and we get 1 minus x. So we want to set both of those factors equal to 0. So this one's easy. We just get x equals 1. That's a critical value. E to the negative x equals 0. To solve that, we can take the natural log of both sides, but not really, because can we take the natural log of 0? No. Right? So these cancel out, but natural log of 0 doesn't work. So there's no solution, no critical value for that part of our equation. We just have a critical value at x equals 1. So that means our derivative here, when x equals 1, the derivative is 0. We need to figure out what happens on either side to see if this is a minimum or a maximum on our graph. So we can put in 0 to test it out. If we put 0 into our derivative, e to the 0 is going to be 1. It's going to be a positive number. Put 0 in here, 1 minus 0 is 1, so it's going to be positive. All the values over here are going to be positive. Our derivative is going to be positive to the left of 1. Then we want to try something to the right of 1. So if we try 2, if we put 2 in here, e to the negative second power, that just means 1 over e squared. That's going to be positive. If we put 2 in here, 1 minus 2, that's going to be negative. So we end up with a positive times a negative, which gives us a negative. So we have a local max at x equals 1.